Welcome. In this lecture in linear data analysis, which has multiple sessions, we'll explore how to separate clusters of data vectors using hyperplanes. The main concepts for this lecture are that in binary clustering, we have two subsets of these vectors. And we'll discover that if these are found, for example, by the k-means algorithm, that they're separated by a hyperplane. If there are multiple clusters, there are multiple hyperplanes that are involved in this separation process. One problem that we can think of as we go through this lecture is how does k-means clustering partition the data? Well, we can also use clustering for classification, and that will be an important part of linear data analysis as we proceed. Let's think about the output of the clustering. In the k-means algorithm, what we have are k-centroids, and we're representing them as vectors that are the centroids. And to find these, we use the L2 norm. Strictly speaking, we use the square of the L2 norm to find these. And the problem that we may be facing is, if we're presented with a new vector, can we classify it as being in one of these k original clusters? And we'll simplify this for now by thinking about binary clustering for classification. Let's think about cluster 1, which has a centroid G1, and we'll think of that as the positive cluster. And then we'll think of the other cluster, which has centroid G2, as being the negative. So we'll think of two subsets, one positive, one negative. That is, there's some decision that has to be made about this new vector, U. And the geometry is that binary clustering using the L2 norm, or the square of the L2 norm, has a hyperplane that separates the clusters. Let's think about the geometry of this. Let's imagine that we're interested in a vector that's on the boundary. And what that means is that the squared distance of the vector to the first centroid is the same as the squared distance of the vector to the second centroid. Let's draw this in a 2D example. Here we have cluster G1 represented as centroid G1, and here we have cluster 2 represented as centroid G2. Now imagine that we have a new vector, V, and the vector V has some determinable distance using the L2 norm, or the Euclidean norm, to that first centroid. Likewise, it has a distance to that second centroid. And when those distances are equal, well, we can recall from ancient Greece the geometer Euclid, and Euclid defined a line or a plane as a set of points that are equidistant from two given points. And so what we can do is we can say, well, the set of points that separate these two clusters must be in 2D a line, or in 3D a plane, or in n dimensions a hyperplane, and it will turn out that this hyperplane is perpendicular to the difference vector between the two centroids. Now, let's work out some of the algebra.